Batch deployment is a method of deploying machine learning models where predictions are made on a batch of data at scheduled intervals. This approach is particularly useful for scenarios where real time predictions are not necessary, and it allows for efficient processing of large data sets. In this presentation, we will explore the steps involved in configuring compute resources for a batch deployment, ensuring that your model can handle the workload effectively and efficiently. Compute resources refer to the hardware and software infrastructure required to run machine learning models. This includes CPUs, GPUs, memory, storage, and networking capabilities. The choice of compute resources can significantly impact the performance, cost, and scalability of your batch deployment. It is crucial to understand the different types of compute resources available and how they can be optimized for your specific use case. When configuring compute for a batch deployment, selecting the right type of compute resource is essential. Options include virtual machines, VMs, containers, and managed services like Azure Machine Learning Compute. Each option has its advantages and trade-offs. For instance, VMs offer flexibility and control, while managed services provide ease of use and scalability. The choice depends on factors such as workload size, budget, and technical expertise. Provisioning involves setting up the necessary compute resources to run your batch deployment. This includes selecting the appropriate VM size or container configuration, allocating sufficient memory and storage, and ensuring network connectivity. Proper provisioning ensures that your deployment can handle the expected data volume and processing requirements without performance bottlenecks or resource shortages. Azure Machine Learning Compute is a managed service that simplifies the process of provisioning and managing compute resources for machine learning workloads. To configure Azure Machine Learning Compute for batch deployment, you need to create a compute cluster, specify the VM size, and set up auto-scaling rules. Auto-scaling allows the cluster to automatically adjust the number of nodes based on the workload, optimizing resource usage and cost. A compute cluster is a group of interconnected VMs that work together to process data. Setting up a compute cluster involves selecting the appropriate VM size, configuring the network settings, and defining the cluster's scaling policies. In Azure Machine Learning, you can create a compute cluster through the Azure Portal, CLI, or SDK. Properly configured clusters ensure efficient data processing and resource utilization. Auto-scaling is a feature that automatically adjusts the number of compute nodes in a cluster based on the workload. For batch deployments, auto-scaling ensures that the cluster can handle varying data volumes without over-provisioning resources. You can configure auto-scaling rules in Azure Machine Learning to specify the minimum and maximum number of nodes, as well as the conditions that trigger scaling events. This helps optimize cost and performance. Monitoring the performance of your compute resources is crucial for ensuring the efficiency and reliability of your batch deployment. Azure Machine Learning provides tools for tracking metrics such as CPU and memory usage, disk I/O, and network traffic. By regularly monitoring these metrics, you can identify potential bottlenecks, optimize resource allocation, and make informed decisions about scaling and provisioning. Optimizing resource utilization involves fine-tuning your compute configuration to achieve the best balance between performance and cost. This can include adjusting VM sizes, modifying auto-scaling rules, and optimizing data processing workflows. By continuously analyzing performance metrics and making necessary adjustments, you can ensure that your batch deployment runs efficiently and cost-effectively. Effective cost management is essential for maintaining the financial viability of your batch deployment. Strategies for managing costs include selecting cost-effective VM sizes, leveraging spot instances, and optimizing auto-scaling rules. Additionally, monitoring resource usage and setting budget alerts can help you stay within your financial limits. Azure provides various tools and features to assist with cost management and optimization. Security is a critical aspect of configuring compute for batch deployment. This includes ensuring data encryption, securing network connections, and implementing access controls. Azure Machine Learning offers several security features, such as virtual network integration, managed identities, and role-based access control, RBAC. By implementing robust security measures, you can protect your data and compute resources from unauthorized access and potential threats. To illustrate the concepts discussed, let's consider a real-world case study. A retail company uses batch deployment to predict inventory needs based on historical sales data. By configuring Azure Machine Learning Compute, they set up a scalable compute cluster with auto-scaling capabilities. They monitor performance metrics and optimize resource utilization to handle peak sales periods efficiently. This approach helps them manage costs while ensuring timely and accurate inventory predictions. To ensure the success of your batch deployment, follow best practices such as selecting the appropriate compute resources, configuring auto-scaling, monitoring performance, and optimizing resource utilization. Additionally, implement robust security measures and manage costs effectively. By adhering to these best practices, you can achieve a reliable, efficient, and cost-effective batch deployment that meets your business needs. Configuring compute for a batch deployment involves selecting the right resources, provisioning and managing compute clusters, and optimizing performance and cost. By understanding and implementing the concepts discussed in this presentation, you can ensure that your batch deployment runs smoothly and efficiently. As a next step, consider exploring Azure Machine Learning documentation and tutorials to deepen your knowledge and skills in this area.